Hi everyone, welcome back to another session of Spartans Summit 2026. And the next talk is one of the most fundamental challenges is to basically uncover one of the most fundamental challenge and assumptions in testing world today. For years, quality engineering has been centered around writing test cases, building automation suites, and measuring coverage. But as a system is increasingly AI driven and data powered, the question arises: is writing more tests still the right approach? To explore this shift, we are joined by a quality engineering leader who has spent more than 15 years of driving large scale automation transformations and modern testing practices. Please welcome Rohit Mehta, Practice Head of QAT at Pratham Software. Rohit has been working extensively with global engineering teams to modernizing quality practices across enterprises and SaaS platforms, focusing more on AI powered testing, cloud native architectures, and building intelligent quality engineering ecosystems. In his sessions, Stop Writing Test, Start Training Models, Rohit will explore how testing is evolving from static scripts and assertions towards intelligent systems that learn from defect patterns, production telemetry, and user behaviors. Before we get started, feel free to support our speaker and the session by just spamming the emojis down below, and also share your thoughts in the chat and your questions in the Q&A section, and we will try to address them in the end of the session. Hi Rohit, how are you?
Yeah, so I am fine, Spurs. Thank you very much for the introduction, and I hope I am clearly audible as well as visible.
Yes, yes, you are.
Thank you.
Just one last action item from my side is don't forget, this for the audience, please don't forget to share your learnings on LinkedIn and Twitter and tag hashtag Spartan Summit. And also, I will be also sharing Rohit's LinkedIn over the chat during the end of the session. So please make sure that you are connected with Rohit and you can ask him question one on one, or you can also follow the threads where we'll be posting all the answers to the Q&A. So over to you, Rohit.
Yeah, so my screen is visible.
Yes, it is.
Okay, so let me start. So first of all, hello everyone. Hello to audience. So Spurs, I'm audible, right? Because
Yes,
I'm moving to the presentation mode now.
yes. Audible, loud and clear, and screen visible.
Okay, so if any question will be there, please ping me because I will not able to see the screen of questions. Okay.
Sure, sure, sure.
So guys, hi. So today my topic will be AI powered testing, which is stop writing the test, start training the models. So this will be a mix of theoretical, mathematical, and practical session. So we'll discuss a lot of things which recently in our last panel discussion, a lot of panelists are giving inputs on different areas. So we'll see a little bit more in depth how models do these things, how they calculate the things, how the mathematics goes behind them. Okay, and I'll try my best to explain everything from with the help of any story or some easy context. Okay, so who am I? So majorly Spurs already told you I'm a visionary leader and influential test advocate with strong community engagement. I have more than 15 years of experience in QA automation, and now I am leading AI in testing area. So overall this is my introduction. So let's start and begin our session. So I'll start and begin a session with a 3 a.m. incident story. So let's suppose we are working in an organization, right? And suddenly a payment system goes off of our client, of our product, right? And 3 a.m. we are getting a lot of notifications and mobile alert that some incident has happened and something is broken down. Okay. So 6 hours later, our team has uh, went into the context, check what is broken down, and we have found that there is a classic break in the payment loop or a code in the loop. They have missed something. Due to that, this issue triggered, and we got a lot of incident notification from the 3 a.m. right. But surprisingly, the manager, the leads, the stakeholders came to you and asked, "What is your regression test suite was doing? You already have 20,000 plus test cases and all are green in the pipeline, but still the bug is here, right? So you have a lot of coverage. but you don't have the intelligence. That is the major pain area, because this is where we struggle. When we have a lot of big products in place, we have n number of, let's say, big QA team, people are writing a lot of test cases, and every tester have somewhere in the mind to write as much as possible. The coverage should be, every tester will try to write as maximum as possible, negative, positive, edge cases, boundary, so the coverage is very huge. But somehow we are lacking towards the intelligence, right? So that's the gap we are here to close. This complete session will take help of AI versus these type of incidents, how LLM plays in the picture, how we can create the guardrails. Everything will drive from this session. So the practical problem here, you can see office, the people are sitting, they're working a lot of work. So everywhere, everyone is writing a lot of regression test suite, right? So once the product starting, regression takes few minutes, then gradually it begins to few hours, then it moves to take a lot of hours, right? So again, flaky test cases create noise, and it will also sometime lose the trust on the automation, right? So these type of problems start coming up when we are building the product gradually and our team has expanded a lot, right? So the testing bottleneck has shifting from writing the test to managing them effectively. So the bottleneck is right now is not writing the test cases. It is now the managing the test cases, because once we have n number of test cases in place, right? We have sanity, prod, pre-prod, UAT, right? Thousand of test cases. Then now the challenge comes here is not writing the test cases, it's now started with the maintaining the test cases, right? And the traditional approach are struggling to keep the pace with the modern development velocity. So this is the context which I am setting up here, and now we will move ahead. So first of all, what the traditional things says, more tests are not increasing the confidence anymore, but then traditional people was our management stakeholders always think that the higher the test cases, higher the confidence level, right? So that's why the people in some places, it's a part of their KRAs, like how many test cases you have written in the last quarter, in the last sprint, right? How much bugs you have identified. So now the things are changing. So more tests are not increasing the confidence anymore, they are increasing the overhead to maintaining them. So why it happens, what actually changed? Because now the things comes in with the AI, the mostly the products, the engineering solutions are coming with the AI inbuilt in the products, right? And when AI comes into the picture, there is nothing which is fixed in terms of the response. Every response changes with the context. So now we are moving from deterministic output to the non-deterministic output models, right? So it is very difficult now to test something, a solution or the product which is already having AI in place, because the things are changed now. Faster release cycles. So the transition is coming from, let's suppose previously we are taking 3 week sprint, 2 week sprint, 1 week sprint. Now, if you see, a lot of projects are coming with a overnight release cycles also. So every patch releases, hot fix, major release, right? Those release cycles are getting very fast. So continuous deployments are coming into the picture, right? So it might possible that some of the products needs to deploy multiple time on the production, correct? So now the expectations from the stakeholders are changed. Now they want feedbacks in minutes, not from in hours or in days, right? So that's why the prioritization of the testing is now changing. So next is behavior changing post deployment, right? So now gradually industry is changing. Now we are working on multi-tenant solution, a lot of multi-tenant solution, multi-tenant with multi-client, right? So there will be a feature flag. Suppose one feature is available for client X, it should not be visible for client B, right? So this is also one of the challenge coming up, right? So gradual rollouts, feature flags, code behaviors are changing in production, because in production features, A/B test, etc. are changing. Also now pre-deployment testing can't change configuration dependent issues, because on our pre-deployment or pre-productions, right, we need to test everything. So if we are going, let's suppose we have 90 clients, and on the 90 clients we have the same system which is working. So it will be very difficult that if out of 90 clients we will test individual client on individual type of feature, right? So this is also one of the challenge. Next is too much runtime data. So we have a log, matrices, traces, user telemetry, massive data we have available, right? But most of the teams are lack tool to extract them and use them. So we need to also give a thought that what data we need to consume to write those test cases, to create our test strategies, right? What are the logs which are available at the production? Is it helpful for us? Can we write something with those matrices, traces? So these type of things are changed. So our mindset also shift from traditional testing to AI based testing. So next is the shift. Again, old approach, write more test cases, right? So when confidence dropped, the incident was always to add more test cases. This was the previous approach. Might possible that you have faced that if something is broken on the production, quickly your test lead or someone come and say, hey, add this test case into our regression cycle or inside our suite. Correct. So more unit test cases, more integration test cases, more E2E scenarios, right? So our assumption always says higher the written test cases, more the confidence, right? This was our previous approach. But now, new reality. We have to learn from signals. Quality teams now treat testing as a data problem. Now we have to think that something which has been broken is also a major due to a data problem. Might be those type of data we didn't create it in pre-production testing, and these type of data any user has created and which already put our system in a buggy state. So instead of writing n number of test suite, correct, we need to analyze the production signal. What are the major business flows? What happens if something in some duration, let's suppose a system you are testing, and on the time of Christmas, on the time of New Year, a certain different type of activity started onto the system. You have to be understand that this system support what type of seasonality. Do we have anything specific during any certain hours? So you have to give a thought. What in terms of testing, be it a functional, non-functional, what we can improve. So this shift we need to bring into the system. So it means we have to focus towards data now. So testing is become a data problem, not just a coverage problem. We need to always focus, and now the shift start. So again, what training model means practically. So what I usually saw in day-to-day activity, we just gradually use any of the LLM model, be it Claude, Anthropic, OpenAI, any. We usually do some type of work using them, correct? And we never give a thought process that shall I train any model? Let's suppose I am using OpenAI GPT, right? A basic thing. So shall I set the right context to it, or shall I use just writing the prompt and start working on it? So this we will see now in subsequent slides. So when we talk about training the model for the testing, we are not discussing the abstract AI theory, correct? So how our historical data will make our whatever LLM we are using to train our models. First, learning from the past defects. So let's suppose if we have a list of past defects of previous release versus the work we have done so far for the new release, if we ingest this data to any of the model, it will start training itself. It will get no understanding that what usually breaks, correct? So it will start learning from the past defects using production signals. If we have a production logs, traces, matrices, right? Let's suppose if client agrees and we have the data of production, and if we can ingest those matrices to our LLM, right? Already like LLM have the past defects, LLM now have the production signals. Okay, so after this, prioritizing the risk dynamically. So let's suppose once we ingest these type of input into the LLM, right? So LLM have now a certain type of prioritizing risk feature which will already tell you that this area might be a radius, like a blast radius, This area is usually under risk from your last release, this release testing. This is the gap which I am thinking. So you have to take this. So your model will start creating a historical stability ranking in itself. So next is improving over time. So let's suppose if we are start giving this type of data, right, again and again and again. So with a certain time, whatever your chat context you have, right? So that chat context will start improving itself. So this is one of the example which I am telling you how or what training model means practicality right now. We'll still deep dive more in subsequent slides. So where training signal come from? First question, always people thinks that using AI is just using the chat GPT, Claude or Anthropic, just start writing, prompting, give him some content, start working on it. No, this is not the right thing. So we have to be very clear from where training signals will come. First, Jira defects. If we can integrate Jira, correct, with any of the models, let's suppose take an example of MCPs, right? So I have a cursor or VS Code, Git Copilot, etc. Right? If I'll integrate the MCP of Atlassian with these things, right? So it will start syncing with your Jira versus your model. LLM start auto training from your Jira. So if you are raising a good bug ticket which contains structured information, what broke, what is the RCA, why it went fail, correct? So also you can also commit, like link your commit with those bugs. So it will also see for what fix this bugs has been passed after what fix and still getting the review of that code also internally. Second is CI failure. If you push or give all the git artifacts, let's suppose you have a git or a jenkins to your LLM model, right? So it will also get and start train itself, like on what basis your CI is failing, what are the issue, is it a flaky test case, or generally you are getting stale element or whatever. So this two things will be a part of training signal. After this, logs and telemetry. So if we have a logs available, correct? So start ingesting those logs into your LLM, application logs, error traces, performance matrices. Okay, what is the runtime? So it will start internally. These signal will start internally to train your LLM model. So user behaviors are very important. So user behavior will play a very big role because whenever you want, that AI will take the call that whether which is the high priority business flow and which is the low priority business flow. So this user behavior will comes into the picture. User behavior will tell LLM that these are the major user business flow which most of the user hit. So it will create those pattern internally and always take care whenever you are trying to do some sort of testing or some sort of code changes happen in any of those business areas. So next is incident postmortems. So whenever you have a incident happen on production, so those RCAs we needs to push into the LLM model so that it will work as a RCA model also. So it will tell that what broke, what we fixed, what was the reason. So it will give a more clear picture to the LLM model. So as per me, these five major training signals will help you to train your LLM model. Okay, so again you already have the data, you are just not using it systematically. So I think most of us have all these type of data available. The challenge is how to use it. So practical use case one, smart regression, real value delivered today. So this we will discuss. So let's suppose we have a traditional approach. We run entire suite, 20,000 test cases, execution time still 4 to 6 hours. Some result 95 pass, 3% flaky, 2% failure. Most of the tests irrelevant to the changes, but no way to know which one matter. Majorly it happens someone write a code of block in some module, but as a picture we need to run everything. We need to run all the regression suite to cross check is anything impacted or not. We don't have any major signal maker which will take us this class, this class, this class. You need to play and rest you can still don't touch because this is not the part of the PR or the change from the developer, right? So now the AI assisted approach, we will ingest into the system or create into the system, run risk prioritization subset of 2000 test cases out of 20,000 test cases, execution time 20 to 30 minutes, result is 85%, 5% and 10% failure, higher failure detection rate with 90% less execution time. But how it happens? Model inputs. We gave PR changes. We have integrated PR with LLM model, right? So every PR, whatever it is raised, it will scan, read, take the call, and tell you what to run, what not to run. Past defects. If those classes, those features already have past defects due to certain changes of lines, it will add all those test cases inside it. Module risk. If he have the knowledge, LLM has the knowledge that this is a module which is a business agnostic part, highly used by the users, right? So it will increase those testing areas, test cases, and it will create that type of test suite at the runtime. Blast radius, dependency on depth, and change frequency. So these type of the model inputs we need to give. So give me a sorry. So next is the risk model breakdown. So let's suppose we have taken example of two classes, payment gateway.js, user profile.css, right? How system is intelligent. Let's suppose we have two type of developer. One is new hire, one is senior. Historical defect rate already high, 5 bucks per year per sprint or anything, right? Second one is low. Complexity 50 and 10, blast radius critical low, and risk score already calculated by the AI, 0.95 and 0.15. Correct. So the model, how model will work? Let's suppose it have the integrated Jira. Correct. It has all the information which programmer taken what type of story, how much code, because we have already linked Jira with our Git. So it has all type of information, right? Who is the old one, who is the just a new developer we have added, and what type of files it has modified, correct? So it will take all the information, create a historical data accordingly, right? So if the high score of the risk is 0.95, it's very risky. So what it will say you, whatever this guy is writing, make it a human review, correct? And whatever the second person user profile CSS has been changed, the confidence is high because it has a risk score of 0.15. We can directly merge the code to the system, or we can directly run the smoke test. If we talk about the testing, we can just run a small subset of test instead of the person who is writing the payment gateway.js and he is modify something, risk score is very high, run most of the larger part of the test suite. So this type of risk breakdown model internally LLM do. So next is practical use case number 2, test generation, right? So AI powered test generation goes beyond simple template. By analyzing code changes, defect pattern, existing test coverage, model suggests relevant test scenario that developer might overlook. So we'll start discussing that point by point. So first is diff based test suggestions, right? So let's suppose developer has modify any new function, right, or any existing validation logic. So now the model will start doing the exercise on the code path, include all the boundary condition, what he has written, right? What can be the suitable test generation for those changes, correct? Also, what can be the suitable test data for that? So diff based test suggestions also it will start giving us. Second is edge case from the defect clusters. Let's suppose it has the historical defect data, right? It will tell that this historically on this feature this type of defect data came in, correct? So now this particular line of code has been modified, so it will start giving you the test cases by analyzing the historical bugs as well as the new changes, correct? So let's suppose if null pointer error cluster around certain patterns, the model recommends null handling test proactively. The model will push you again and again. This is the major thing which you need to check, because in past we have n number of times, let's suppose login functionality is there, and for 45 times if the code has been changed for that functionality, somehow 45 or 40 times null pointer exceptions come into the picture. So model will strictly push you to test those scenario on highest priority. So third is API contract variation. For API changes, right? So whatever we change in the API, so model should be so much trained and smart. It will generate all the test cases regarding the formats, your post body, your headers, authentications, everything it will do in terms of API contract variation. It will create a lot of test cases for you. So sometimes we do the API testing, but we forget how to test the non-functional part. So it will also suggest you, API contract, how will you check the authentication? How will you test the JWT? Are you missing any OSAP top tap vulnerability to test the API? So it will give you all those type of pictures or test cases also. Correct. So now what is the best practice? So best practice is start with AI generated test suggestions, then apply human validation, review for correctness, add assertion, and verify the business logic alignment before committing. So the main line is you have to do the human validations also whenever test generations. We are completely focused on AI side. So let's now we are going deeper and deeper inside the LLM training part. So next is the training vectors. So we don't just throw code at an LLM, we vectorize our Jira defects. So the thing is this, everything going towards LLM is via vectors. So vector, whatever code repo will sync or whatever MCPs will integrate, everything it's take as in vector, as an embedding to the model, right? So let's suppose if we see 50 bugs labeled null pointer exception in the login module, our model learn to always generate null checks for any login related PR. It is not just guessing, it's a pattern matching against our own history. So how it works? See, this is the bug summary. Let's suppose null pointer exception, module login, and 45 more times it has occurred. So embedding, it will do all the embedding. It will push that embedding store to the LLM trainer. Fine tuning started at the back end. So whenever any of the PR changes push for the login module, it will start, or it will give you the text generation regarding null checks, login edges, all related PRs. So it will do this type of analysis at the back end. So let's see the practical use case number 3, failure prediction. Flaky test predictions. Machine learning model analyze test execution history to identify flaky tests before they erode trust in the CI. So first is flaky test prediction. How AI will do those type of failure predictions. So let's suppose we have a pattern like inconsistent timing, environmental dependencies, right? So how AI will help us, we'll see more deeper, right? So second is risky build alert. Whenever a build enter into the CI, model assess its risk profile based on change file, author history, time of day pattern, high risk build trigger enhancement, scrutiny, additional reviews or expanded test coverage. It will give you the risky build alert that whatever you have given for this particular CI pipeline, it is risky. How it will do, we'll see in the next subsequent slides. Release instability scoring. Internally, it will do all type of release instability scoring also. So before deploying to production, model score release candidate based on the test results, code churn, dependency update, and historical stability of included changes. So it will do all these type of predictions. So the prediction integrate directly with DevOps workflow, triggering automated response in CI/CD pipeline, deployment system, and incident management tools. Sorry. So these are the predictions which we usually do by AI. So how we will do? We'll see this. So let's suppose will give 6 months of CI logs, or you can say that our CI pipeline is already integrated with our LLM models. So it has all the CI logs on the daily basis. So this log says that if you'll see here, we have a runner Ubuntu slow. We have a runner which is marked as slow runner. It might be due to low configurations. And gradually, day by day, we have run all the test cases or test suite. Someday it pass, fail, right? So it will create an internal history. Correct. What are the flaky test cases? Sometime it might happens that some test cases works on Monday, but it fails on Tuesday, or it works on Wednesday, fail on some other day. So it will create that flip history also. So it is called environment fingerprinting. So what type of runner we are using, what type of test suite we are running on those runner, what is the history of the test suits, what are the history of the test cases, which are the flaky, which are non-flaky, right? It will create all the environment fingerprinting for you. So let's suppose once you run everything, it will train a classifier on these environmental fingerprints, and when a test fail, the model tell us that CI test diagnostic 85% tests which are failing is due to flaky behavior, not a fluke. It is a flaky test. So it will directly say us skip debugging and report as flaky, because if you run it sometime later, it might possible these will run. There is a no change from the development time, development side. There is a no change on the elements or any behavior or any post body request response. Nothing is changed. It is just due to the flakiness history. I already have the history because I have the data. So it will tell us due to these training vectors. So where AI actually help us most, right? So first is prioritization. So AI help us ranking thousands of test cases by risk, execution cost, and coverage value. This transform unmanageable test into a focused, efficient regression runs that complete in a reasonable time frame. So prioritize, it will help us to prioritize which test cases we need to prioritize out of which test suite. So it will give us, also it will help us in the pattern detection. So whatever, if we need to any change comes into the picture, it will tell us that this is the pattern of breakage. If some sort of commit happens, this will break. So it will automatically tell us that you have to see those type of modules if this type of code has been committed. So basically with the time, it will also reduce the noise, and it will tell us whatever. Let's suppose something failed on CI pipeline due to environmental fingerprinting, it will tell us that these are the flaky test cases. See, these are the flaky test cases. There is no need to debug. It will save a lot of time for us. So AI is not a magic test writing, it's an intelligent amplification of human testing decisions. So it will also reduce our alert and fatigue. So let's suppose if 85% test cases are flaky, let's suppose if 1000 test cases we have run, and certain day 850 test cases are failed, and system already tell us that this is my confidence, it is due to flaky test cases, don't need to skip, rerun the build. So it will save a lot of time for us. So where AI fails, correct. So AI is not everywhere. AI sometimes fails also. Being a realistic, I have covered this slide also. So first is hallucinated scenarios. We always know that AI will start thinking more than us. It will, due to giving us more coverage, started hallucinating wrong scenarios. Sometimes it give us out of the context thing. So hallucination is the biggest problem with the AI. Second, confident but wrong outputs. So sometimes model lack awareness of their own limitation. They provide risk score and test suggestion with high confidence even when training data is sparse or irrelevant. Whatever we have already pushed as a training signal is irrelevant or wrong. But this is the source, the truth for the LLM model. So due to that, it started giving you the wrong answer because you have ingested poor quality of data as a training data to LLM. But out of that poor quality of data, LLM will create the confidence score and it will give you a lot of inputs. So this is also one of the problem. Sometimes it's bias from bad defect data. Let's suppose we raise some defect into the Jira, and we have a practice of writing a bad defects. We are not giving the right defect tracking mechanism. We are not writing properly steps and the labels, the screenshot, the data. So it will give you the whatever it has, right? Bad defect data history it has. So it will give you anything out of it only. So missing domain context, right? If you didn't set the right pace, the right context out of it, correct? So model is don't not able to understand what your product does, right? You have to give those rag, those knowledge bases. You have to give those knowledge repositories first. You have to set the context to the LLM, because if you blindly sit and start working with the LLM without setting the right context, so you have to create the rag, you have to create the KB articles, you have to ingest into the LLM so that it will give you a right, as much as right outcome to you. So AI output is a recommendation, it's not a verdict. So we'll start thinking and look into the more how we can work onto it. So it is just a human helping into the human decision making. It's not replacement for expert judgment. So how we validate AI practicality. So now we are going into the mathematics side. A little bit mathematics, how AI practically validate the things, how a abstract score or confidence score has been calculated. First is confidence scoring. So every AI recommendation included confidence score based on the training data quality and the prediction uncertainty. Low confidence means human review. Explainability. Model must explain their reasoning. Why was this test prioritized? Which feature influenced the risk score? Explanation enable engineer to assess whether the model logic align with reality. So next is guardrails, that we have to put some hard constraint to prevent the dangerous recommendation. Okay. So after that comes into the human review for the high risk. If after doing all these exercise, we are AI is giving us a signal that it's high time for a human review, because whatever calculation I am doing internally and it is giving me X number or X output, which says it low confidence rate, low explainability, low guardrails, just go for a human review. So we'll see now in the subsequent slides. Guardrails that actually works. First, block destructive test suggestions. We have to prevent AI from recommending tests that delete production data, modify user account, or perform irreversible operations. So we have to be very strict while writing the guardrails for our context or prompts, or if we have the MCPs in place, we have to be very strict with these guardrails, because let's suppose if we have configured our MCPs in the agent mode, right? By giving them allow all permissions, these are the destructive areas which will be might be irreversible operations. Second is policy filters. Whatever your organization policies, coding, like coding guidelines, review guidelines, PR guidelines, if you are a SDET, right? What is your automation writing the code guidelines? You have to strictly given them as a rule into your uh, any of the vibe coding tool which you are using with integrating with LLM, because security critical. Whatever we are doing, making any changes, we must be very clear with those your policies. Next is domain invariants, correct? So you have to give proper domain information. You have to create rules inside uh, your vibe coding engine or LLMs, that these are the domains which I am focusing. And let's suppose if account balance is greater than zero, order total equal to sum of line items, sometime it might possible you have to tell him that this is my logic, not the industry logic we are using. It might possible a customer have something else into a domain, he is creating something else out of the box, which has its internal logic. You have to tell them strictly. Next is risk threshold. Define what is the acceptable risk level for different deployment stages. You have to tell them that stage tolerate the higher risk than production. It should be clearly given to your LLM, your vibe tools or cursor or anything, that whatever I am testing right now here, You have to be very, very clear. If any pipeline, any production suite, any stage automation is running, the instruction should be very clear. The stage tolerate higher risk than production. So whatever you are doing in the stage, just do a very deep dive. You have to also tell that feature flag changes allow more experimental than generally available feature. Whatever you need to be do, you have to be very clear with those risk thresholds. So these guardrails evolve as a team learn which constraints prevent real problem versus which create unnecessary friction. So with the time, basically with the time you have to be mature your guardrail system, so that unnecessary guardrails are also problematic for us. So how to calculate the confidence in AI generated test? So Sparsh, any questions so far? I am taking a break for 5-10 seconds for water.
Hi Rohit. So there are a couple of questions in the Q&A, but due to interest of time, we can answer them
Okay.
in the miscellaneous thread.
Okay, no
We
problem.
are also on time, so if we can wrap in like 5 to 7 minutes, that will be wonderful.
Okay, okay. So I will just cover this topic, and I have, I think, 4 5 more slides.
Yeah.
Let me.
Thank you so much.
Okay, okay. So
No,
let's
but
look.
the talk is very interesting, so I didn't want to interrupt you. But
Sorry, let's do it. Let's do it. Okay. So let's see. In practically now we are coming into the mathematics side. So I have tried my best to cover this mathematics. So how confidence score internally LLM multiplies or create, right? So confidence score is equals to model score multiply by historical precision into signal strength into context match divide by risk multiplier. So it's a big formula, right? So for a time being, let's listen this slide, then we move practically and we'll come back again. We'll say take some example, come back here, and this is the major crux of the complete talk what we have done so far. So model score basically start from 0 to 1, and it's a raw AI probability or ranking score which internally model gives it. Okay, so this is one thing. Historical precision is the past accuracy of similar AI suggestions. So this is also some sort of score right now for you. Third is signal strength, quality of input signal, any defect bagged versus pure prompt. This is also something. We'll touch base, don't worry. So next is context match, relevance to current code changes or dependency. Or next is risk multiplier or penalty or high risk domain. Correct. So risk multiplier moves from 1 to 2, max 2, start with 1. Okay, and context and everything like context match max 1, model score max 1, historical precision max 1, signal strength max 1. So I'm taken some example, let's say 0.8 0.711, this some multiplication happen and outcome comes below below zero point 0.7, so it is 0.25. So low confidence. So we'll see how, and we'll come back again. Let's move next. So this is a example which I tried my best to create. So let's suppose you are going with some of your family or some friend or some people, right? So you are going for an outing for a dinner, right? And you want to eat pizza, and you just wrote on the AI. So we'll touch base first. Model score. Hey AI, I want to eat pizza, right? So AI just do the calculation, model scoring. He's just reviewed, checked everything, Google, etc., and it gave you that Yugi's is the best pizza counter for you. So you have taken the call, correct? And let's suppose this is the max uh, match model, highest model ranking. It has zero point 0.9. So it suggested you. So you went there, you ate the pizza, you said, I loved it, scored zero point 0.9. Okay, so this is, uh, this is why this internally does, because it has all the information, all the reviews that people loved it. So zero point 0.9 it has given you and suggested you. Next is my track record. What is my track record? Let's suppose I have eaten it, I have given the feedback, right? So now 60% is your track record, which is matching with the people feedback. So model says, yeah, your feedback is something 60% accurate. You've written, I didn't like that. Something is this. So it gave you mark of zero point 0.6. Next is evidence quality. So if you have put it some evidence there that I have add there, this is my pizza, this look like this, it was very nice. Now model is very confident. It gave you one, correct? So it gave you model score, your historical precision, your signal strength, that you have given some input also. You gave some evidence, so it has given you 100% marks into the signal strength. Next is your context match. Sorry, yeah, next is your yeah. So context match, right? So next context is, let's suppose Lugis Pizza is very noisy counter. A lot of people are roaming here and there, and your context was you want to go in a silent place, but still AI suggested this. So the context is not matching with you because you are just wrote that I need some silent place to eat pizza. It should be best in the place and on. So it will give you mark of point 0.5, that AI is not able to give you the complete marks in the context match because your context is irrelevant with the AI input or feedback given to you, right? So next is, let's suppose, what is the in the denominator is risk multiplier. So let's suppose you need to go to eat pizza for discussing a sales pitch for a silent place, but unfortunately you landed up in a Lugis, which have the good pizza. You have also given the evidence. Situation fit doesn't match, and the talk which you want to do at that place is not the right place. So this is a high stake area where you have set it down a lot of noise. So it is 2 marks as 2 risk multiplier, highest risk you have taken. So it will be a division of 2. So the complete calculation has been done and the final confidence report card come with 0.13. So it is a too risky. Do your own research. If you want to go and eat something like this, when you put the context next time, or let's suppose I put the context, I want to eat the pizza at the Lugis place, it should be very good pizza, and I want to go in the silent place for discussing my client stack or something, it should give you the confidence score of 0.13, that as per LLM this place is good, but do your own research because you are going to do this type of things. So internally this is a example I have given to you in terms of the storyline, right? So something happens similarly here. AI suggestions comes in when we do a practically 0.8 historical precision. Let's suppose whatever work we are doing, it have all those testing signals input into it. It gave you that yes, you are going to test this module as per these changes. Historical precision rate is 0.7. There are 2 3 bugs already raised on it. This type of historical work, if someone has done and modified this module, these classes, something fails, it gave the maximum one number to the signal strength because already bugs are in the place. Context match, whatever test you have done or run, it is okay to cover everything, so it has given some sort of this. So whenever you wrote that this is a payment gateway which I need to test, so it has given you the critical marks too, because it is a critical blast area, the core of your application. So after all the calculation 0.25, it is saying that route to human for review. Whatever changes you are testing here, just go to review. Human review needs to be done. Don't dependent on me. So this is the way calculate of confidence number in AI generated test cases via LLM. Okay.
Hi Rohit, sorry to interrupt. Like as we are a bit ahead of ahead of our schedule, so if we can just wrap the talk in
Okay. 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 Okay.
as much as possible.
Okay.
Thank you.
So let's the final talk. How this fit in the existing framework, Selenium Playwright API automation. Everything will work. No need to replace. Just you need to add intelligence layer, signal analysis, text generation, and feedback learning. So there no need to do anything, something which need to draw from the traditional way. Everything will be there. Just you need to add a AI layer over it. Okay. So thank you very much. If you want to go deep dive into the AI, LLM, everything, whatever we have covered, it's a very glimpse of it. And if you want to dig down, this is my book available on Amazon, Flipkart, and Notion Press itself. You can buy it, learn it, a lot of things inside, user case study, everything I have added here. So thank you, Sparsh. I think I have sum up a lot of things. So thank you very much.
Thank, thank you so much, Rohit. This was very detailed and very thought provoking session, and the idea of shifting from writing individual test cases moving forward and
Yeah,
enabling a complete intelligent testing system is like shifting from challenges that we face in the traditional testing mindset.
yeah,
It also opens us for a lot of more conversation on how testing and roles of testers are evolving. Thank you so much again. Sorry about the timings.
no problem.
We were not able to take the Q&A, but I will share. There are some interesting Q&As in the Q&A sections, and I will be sharing that with you so that we can share the answers back to our audiences.
Yeah. So anyone who wants to add can take the LinkedIn and come and join with me. Okay. So I think you have already shared the LinkedIn, right?
Yeah,
Okay.
I'm just resharing the link again in the chat. So please feel free to follow Rohit and reach out to him. He's very supportive and reachable. So if you have any thoughts, any questions, any follow-ups, please feel free to ping him in the chat.
Okay.
Thank you so much, Rohit.
Bye bye, guys. Thank you.